Hey everyone, thank you for coming to this talk. My name is Euccas Chen. I'm a software engineer at Pinterest. And this is Tobi Ogunnaike. He's also a software engineer, and we work on the same team. So may I know anyone in this room use Pinterest? I see many hands. Awesome, thank you. Pinterest is a visual discovery engine. It's a positive corner on the internet. Our mission is to bring everyone the inspiration to create a life they love. Today, there are over 300 million pinners all over the world every month on Pinterest, and they have created more than 200 billion pins. To support the massive amount of pinners and their activities, our infrastructure has a huge footprint. Internally, we have thousands of services running, ranging from the microservices with a handful of CPUs to the large monolithic services, from machine learning jobs to data processing jobs, from Java Go services to Python, Node.js, or MySQL services. We manage a pretty large infrastructure. And the team I work on is the engineering productivity team within the infrastructure. Our team builds and maintains the fundamental platforms and systems that every Pinterest engineer would use every day for their work. For example, we own the source code control, the build platform, and CI/CD platforms. Our goal is to provide a fast, safe, and delightful path from an idea to production. So in the next 30 minutes, we will cover 3 topics. The first one is we are building a new CD system for Kubernetes at Pinterest. We want to share with you how we design and build this system. And secondly, we want to share how we adopt this system and help the other engineering teams to deploy and migrate their services to Kubernetes. Finally, we will share the lessons we have learned along the way and hope that's something you can take away with you today. Before we get into the CD system, I want to give you some context of how we adopt Kubernetes at Pinterest. Back in 2016, our first Docker project started. In 2017, we evaluated multiple container orchestration solutions and decided to go down the path of Kubernetes because of its flexibility and extensive community support. Thank you to everyone here. And in 2018, we started to build our Kubernetes clusters and run some of our production services on those clusters. So far, we have built our own CRDs to hide the complexity from Kubernetes. And also, we integrated our existing infrastructure components into our clusters, like traffic, security, metrics, logging, and so on. One last thing is, this year, we started to enable continuous delivery on Kubernetes. Talking about Pinterest CRD, we implemented our own Pinterest CRD to model the unique workloads we use. Those CRDs bundle multiple native Kubernetes resources together, so they work like one single workload. Now we have 6 CRDs, and they greatly simplified the configuration needed. As you can see in this example, using our CRD, our developer writes a config file with 25 lines, and then our controller will translate those 25 lines into the native Kubernetes resource definitions, that is 380 lines. So from 380 lines to 25 lines, that's more than 10 times reduction. For us, this is really great. So after talking about Kubernetes, let's switch to some context of deployment at Pinterest. We have an in-house deployment system tool called Teletron. Teletron has been up and running since 2016. It has been 4 years. Today, the majority of our internal services use Tidytron to deploy their code to virtual machines on AWS. Today, every day, Tidytron runs close to 7,000 deployments. We have open source Tidytron, so if you are interested, you can find its code and documentation on GitHub. Now, I want to know how many of you ever deploy your code to Kubernetes? Great, most people did. And did you find that's easy?
Thank you.
Yeah, thank you. We feel the same. So while we adopt Kubernetes into our organization, we find there is not an easy and a nice way for our developers to deploy there. Here are some challenges we are facing. First one is complexity. Kubernetes itself has a host of concepts and objects. Although those are interesting to us, because we are the people who like and support Kubernetes and want to be part of the community. But we cannot expect our developers who work on different products or projects to have the same interest as us. We cannot expect them to be very comfortable with getting into all the details of Kubernetes. On the other hand, in order to deploy to Kubernetes, developers need to prepare many things: the manifest files, Docker images, and maybe other artifacts, or maybe the particular access to a cluster. So all those are just complicated. The second challenge we find is our current tooling does not support end-to-end experience. Developers, they often need to jump among multiple systems, such as build or testing or Artifactory, in order to deploy their code. Especially if something is broken in the whole process, it's painful for them to locate the errors and figure out what's happening. Lastly, we do have a few Pinterest-specific problems. For example, we invested heavily in our internal infrastructure and tools. So how can we integrate those existing tools into the deployment process? Like our OpenTSDB-based metric system, our project ownership system, and security tools. How can we integrate them all together? Another thing is our old deployment system, Tidytron, does not support Kubernetes. And it only has very, very limited support for auto-deploys or continuous deployment pipelines. But that's what we need. So we need a solution to answer all those questions. What we want for deploying to Kubernetes are three things. First is make it easy. We want to abstract away the complexity. We want the developers only need to do the minimal amount of configurations, and they only need to interact with one interface for their daily deployment work. Number two is we want the tooling to cover the process all the way from code commit to code deployed. And also, we want to have good visibility, telling you where is your commit, has a build started, and is the artifacts ready for deploy? And if there's something goes wrong, where can you find the logs and errors? What should you do next? All this should be covered by the end-to-end support. Last thing, customization, which is very important, meaning customize the features we need the most for our organization. For example, integration with our infra systems, having the deployment pipelines, and enable seamless integration, migration from Tidytron. This is what we want. So how can we get there? We look at a few existing solutions like kubectl or pcloud. Pcloud is a command line tool we developed at Pinterest Using pcloud, you can create a deployment or look up the pod container logs. And we also look at some other open source solutions like Argo CD or Spinnaker. We feel some of them provide pretty powerful functions and we could benefit from, but none of them perfectly meet all we need for CI and CD at Pinterest. So why this picture is here? Because I want to use this picture to show this is a feeling we want our developers to have when they think about continuous delivery. Our developers are very busy. They move fast to build new features or resolve incidents. So when they need to deploy their code, we want them to feel as happy as seeing a puppy is delivered to them. With all those considerations, we started to build a new CD system called Hermez. Hermez is a user-facing system for CD at Pinterest. We expect it to be the single pane of glass that our developers need to use. Hermez focuses on Kubernetes first, but meanwhile, from the very beginning, we designed it in a way to be able to extend to support other compute platforms. And finally, Hermez provides delightful experience to our developers. Next, I will introduce some of the features we built into Hermez. The features we built into Hermez can be divided into 3 major groups: workloads, and deployments, and CI integration. Let's look at the workloads first. Workload is something you create for your service, and later you can use this workload to deploy your changes to any particular environment. The features around the workload are, first is easy configuration. When you create a workload, you only need to provide your code repository and Kubernetes config file, and that's it. We support different workload types. Because Hermez focuses on Kubernetes first, so we support all the types defined by Pinterest ARDs. It also supports the workload from other compute platforms, such as data streaming or our legacy Teletron workloads. There are also features around operation support. We want to show you how you can monitor your workload healthiness, give you some metrics about the CPU and the memory usage, and access control and notification. Okay, now you have a workload. Then you can use Hermez to deploy commits or PRs from your code repository. We find that deploying the PRs are super useful for our developers to testing or doing code review for their changes. Users can do the operations like rollback, hotfix, or scaling. Continuous delivery pipelines, as I was saying, is a crucial feature to us. So Hermez provides standard deployment pipelines out of the box. In that standard pipelines, we put our recommended stages. Under the hood, Hermez integrates with Spinnaker Orca to run those pipelines. The features around best availability. Hermez tells you what's the current running version, who made the deployment, when it happened, all those details, and gives you the pod and container status events and logs, and also deployment history. The third feature group I will introduce is CI integration. Bridging CI and CD is important to us because we want to visualize the process from code commit to code deployed. So give you the logs for debugging. And Hermez has the build pipelines to support our small service repos or huge model repos. This is a tech stack involved in the whole Hermez deployment process. On the left side is our source code and CI. When there is a commit or PR, there will be something happen to start the build pipelines on Jenkins. And then the Docker images and the Kubernetes manifests will be generated. On the right side is Hermez and the other systems integrated with it. Hermez UI and the API run in separate containers. Hermez API integrates with our ownership system, our metric system, logging, and security tools. Security tools also integrated with both UI and API. Maybe one interesting part on the right side is the Spinnaker. I don't know how many of you use Spinnaker already. We see Spinnaker not as an all-in-one platform, but rather a bundle of microservices, and we can choose what are useful to us. So for Hermez deployment system, we choose to use Spinnaker's Euccas as a workflow engine to enable deployment pipelines. And lastly, workloads will be deployed from Hermez API to Kubernetes or the other platforms. In the tech stack, it may look like a lot of things were going on. But the good news is, from a developer's perspective, they don't have to see that picture. What they see is they create a commit or PR from their command line, and then they come to Hermez to deploy their changes. And sometimes they don't have to come to Hermez because our CD pipelines will automatically pick up their change and deploy to Kubernetes. In the end, developers get a service URL where they can see or play with their changes. So from here, I will hand over to Tobi, who will better demonstrate what the developer experience looks like and how we help the other teams to adopt Hermez.
Hi, everyone. My name is Tobi, and I'm also a software engineer at Pinterest. So Euccas has spoken a bit about Hermez, about the motivations, the challenges we're trying to solve. She also showed the tech stack. So I'm going to switch gears a bit, and I'm going to talk a bit about the customer adoption story. So anyone here who's ever built a product knows that it's one thing to build the product, whether that's software, whether that's a T-shirt, whether it's lemonade you're making. It's a completely different thing to actually get the users, right? In the context of what we're building a new CD platform. This challenge is a bit intensified for a couple reasons. One of them is, first of all, the scale. So Pinterest is a huge company. We have hundreds and hundreds of engineers, thousands of services going on. And people have been doing deployments before Kubernetes. People are going to do deployments in the future with or without Hermez. So that means people have existing habits about deployments. They have things that they expect from the deployment system. So this is a curve we obviously need to overcome when we're trying to incentivize them to use our tool. Another thing is Kubernetes itself, like Euccas mentioned, it's a new technology. So a lot of us here know about the ins and outs of pods, about networking, about access control. But we can't expect some of our product engineers working on specific teams to have that same level of understanding. So when you're trying to get people to actually use your product, this is the fundamental question they're asking. People don't care so much about whether you wrote the most poetic Python, the nicest JavaScript. People just want to know fundamentally what can your product do for them, and they want to know why they should care. So in order to try and answer this question, I'm going to show two quick demos, two videos of demos, where I'm going to try and illustrate basically the value add for Hermez. So the first thing I'm going to do is I'm going to demo a cron job. A bit of context on this. So I wrote this cron job myself. It's a fairly silly cron job. What it does is it pulls a flights API every minute, and essentially it finds the cheapest flights from SFO to Madrid. The context is that I want to go to see El Clasico next year. If there are any soccer fans in the house, thank you. Okay, awesome. So if you can actually use this as well if you're interested. You can see the cheapest flights. So I'm just going to start the video for this demo. Cool. So this page, you can see the deploy information for this cron job. I've already deployed it ahead of time. You can see information on the current status where you can see that it's currently scheduled. You can see when the next run is going to be. So I'm just going to play this. Cool. So in a couple of seconds, it's going to run. So because this cron job is very small, it basically runs really quickly. But a very interesting thing to note is that you can see the actual logs from the cron job. So here you can see the cheapest flight is 175 euros, which is really cheap. Another thing here, you can see the history. You can see basically some of the previous executions of this cron job. And you can see the schedule as well. And this is in plain text, right? You don't have to memorize or try and parse the cron job syntax. So a couple of things I want to call out from that demo. First thing is we're providing first-class support for cron jobs. The reason why this is important is that historically, there have been a bunch of different ways to create and run cron jobs at Pinterest, but we haven't had a very single, simplified, recommended way to do that. But here, we took cron jobs as a first-class citizen. From the ground up, we thought about, okay, what is the experience we want to give users for cron jobs? And that is reflected in the features that we show. The second thing is that we have easy integrations with our existing systems. We're not asking our users to come up with new build systems or have a different way where they keep their artifacts. We're using what already exists, and we're hiding the complexity from them. And the last thing is debuggability. We think it's really important that people know exactly what is going on with their workloads, so we provide the opportunity for people to see container logs, the pod status, whether it's scheduled, whether it's running, whether it's failed, and you can also see the workload metrics. So these could be things like CPU or memory usage. So with that done, I'm going to show another video of a demo. This one is going to be for a service. So this actually relates to the feature that Euccas mentioned before. So in Hermez, we built the functionality for the first time where people can deploy PRs. By PR, I mean any unlanded revision you have, any feature branch you're working on locally. The reason why we did this is because we found in talking to our engineers that this is something that they wanted to use for collaboration. You can quickly work on a feature, create a PR, deploy it, and share the URL to someone to basically interact with that experience. So I'm going to show a video of something I deployed this morning. Okay, don't know, it was a very technical issue. Okay, so this video is going to start from the terminal. Just assume you're an engineer, you've already made the feature, you create the revision, and then you're going to go to the deploys page. You pick the diff, you deploy the diff, and then you can pretty instantly see the deployed version with the easily shareable URL. So if you just watch the video, create the diff. This part is not important. Okay, and this is the deploy UI. You can pick the diff. You get instant validation of your artifacts on the page. This is our deploys page. You can see instantly you get the desired pods increases to 2. And then essentially you can click on the service URL. So this is the silly thing I built this morning, but you can see how in a different context, if you're building a feature, it'll be really valuable to test new UI changes or API changes really quickly and to collaborate with your fellow engineers. So again, a couple call-outs here. So we're providing a new feature. Again, this is something that we got from our user research. And again, we have easy integrations with our build systems, with our artifact stores. And again, debuggability is at the core. We make it very clear for people to know what's going on with their pods, their containers at every point in time. And also operational, like we need to make sure that you can see the metrics, you can see the CPU, you can see memory right from a single non-cluttered UI. We think that's very important. Okay, this thing isn't working. No, last one. Cool. So given that we spoke a bit about the challenges of customer adoption, what did we actually do? What kind of process did we follow to make sure that we had an easier time with this. One of the first things we did was that we made sure we had a reduced scope. So we actually have the support from our platform team to deploy 6 or 7 different workload types, but we made sure that we started with just one first in order to try that out, get some feedback, see what we can learn with people. Related to that, we partnered with early adopters. So these are people who basically were willing and able to try things before they were ready. This was very critical in our success. And also, it's important to make sure you work with people who have different use cases, so you're not solving for the same case multiple times. So when you're working with early adopters, you're going to get feedback. It's also very important to take that feedback, iterate on your features and what you're delivering. And then knowledge sharing. So we made sure we went through a process of sending out bi-weekly updates to our customers. We made sure we did demos like this, but smaller ones as well in the company. We did brown bags as well. And we have runbooks for people to onboard themselves onto our systems. And in the future, we're looking to provide self-service migration tools. So this would basically, again, ease the heavy lifting of people who are trying to use our service in the future. Cool. So on this page, again, we have another cute picture of a dog. But this is basically, we just want to share that we had a success story. So a couple months ago, there was an internal Pinterest hackathon. And the team which owns the home feed part of Pinterest, they reached out to us because they heard what we were building, and they wanted to collaborate. They were really interested in the fact that you could deploy PRs and share that with other engineers. So they reached out to us, we worked with them, we helped them with the process of writing YAMLs, we helped them with figuring out the traffic stuff as well. And this was actually before Hermez was ready. So it was really, really useful feedback for us as well as we were building. And by working with them, we were able to build this, and they ended up winning an award. And as the people who helped provide that, it was super useful to feel like we're enabling people's success. So that's a cute dog, because we were happy after their success. So with this, I'm going to pass on to Euccas just to close on our learnings. It's not working.
Thank you, Tobi. So as the last part for today, we want to share what we have learned along the way. We have been going through 4 stages in the path to the new CD system. The first one is design. We started from user story and UI mockups. The important thing here is to making sure listen to your engineers, having the feedback sessions with the other engineering teams. So make sure what you designed matches their expectation. And after that, we moved on to the MVP phase. Here, we build the minimal set of features. And also, it's important to find opportunities to collaborate with the other teams in your organization. As Tobi mentioned, we joined our company's hackathon and worked with a few product teams. After that, once we have the MVP ready, we started to use Hermez internally in our team first. This is an interesting stage, and we spend much more time here. For example, we may find something we didn't think through in the original design, or something we thought could be very useful. But then we realized, actually, we don't use it that often. And also, we need to find early adopters who can support us, and we help them to migrate some of their services using our system. Finally, we go to the production phase. The key takeaway here is breaking the huge scope into smaller scopes, meaning you can build features for one particular workload first and engage with a smaller user group first. Here are some of the important things we learned. Number one is treat workloads as the first-class objects. We realize what people need for deploying different types of workload can vary. So it's important in your design to have the flexibility so you can customize the design for different workloads. Number two is do not force your user to know about Kubernetes. Deployment system is an abstraction to the underlying compute platform. For the most of our engineers, they just want to see their deployment is running, and if something fails, they can debug it. So abstract away the complexity is a priority. The third one is starting security integration early. Although deployment system is something we use internally, and we do trust our engineers, but we think having the security guardrails is crucial, and it's better to do it early. So find someone in your security team to working from very beginning would be super helpful. Lastly, form is as important as function, and UX language matters. So do spend time thinking about how to make your UI intuitive, consistent, and well-structured. That will make your engineer's life much easier. So that's what we are doing for CD at Pinterest. Here, I want to take a moment to say thanks to the people who work on our CD and Hermez project. Besides two of us, we also have other engineers in our engineering productivity team, and our tech lead and manager, they are super supportive. And if this sounds like something interesting to you and you want to chat or some general question about CD, feel free to reach out to us. You can send us emails or messages on LinkedIn. Thank you. So anyone has questions?
Sure. Oh.
How big is the team that runs or that built all of this? How many engineers?
Oh, our team has more than 10 engineers. For this project, we have mainly 3 people working on it right now.
Okay.
So for the templating portion of Hermez, you mentioned that you start with a small configuration file and then you flesh out all the details that you need for a Kubernetes manifest. What did you use for that templating process? Is it all just code that you guys wrote?
Do you hear?
Could you please repeat the last part?
Yeah, I think.
So did you write the templating yourself, or did you use any templating engine to create the Kubernetes manifest?
Oh, we have our internal template. We have the controller to translate that part.
Okay, thanks.
Thank you.
Thanks.
Can you say something about the underlying infrastructure? Do you have a single cluster where you replay all the workloads to, or do you have multiple clusters, or what is the setup like?
Sorry, what were the options? I didn't hear the options you said. You said something about
the underlying infrastructure where Hermez is deploying to, or ultimately Spinnaker. So do you have multiple Kubernetes clusters, or do you use a single one, or what does the setup look like?
Yeah, we do have multiple Kubernetes clusters. So we have 6 or 7 different clusters.
Okay.
Thanks.
Thank you for the presentation. Is it a hard requirement to use Jenkins and Spinnaker in order to use Hermez?
Jenkins is currently we use Jenkins as our CI platform. So we manage build jobs on Jenkins. We don't use that for deployment. And for Spinnaker, we only use a part of that.
And who manages Spinnaker and Jenkins in Pinterest?
Yeah, our team manages Jenkins.
And Spinnaker.
Thank you.
So what's your solution for configuration management and secret management?
Let's configure my project.
That's a good question. For the secret part, in Pinterest, we have our own security system tools, and also we have the security as a sidecar. So that's how we manage security and secret keys.
Okay, how about configuration management in general?
For configuration, yeah, a lot of our configurations, for example, the workloads or deployment, they are configured as code, and some of them are maybe stored in a database.
Got it. And last question is, are you guys open sourcing Hermez, or is it in-house project keeping closed?
Yeah, we are not there yet, but we do want to collaborate with the community. So if someone are interested, we can think about how we can work together or even open source in the future.
Thank you.
Thank you.
Excuse me, do you have some testing environment in your company? Testing environment.
Test environments?
Yeah.
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 Can you introduce more about it?
What kind of testing do you mention?
Just like performance or some integrate testing,
Yeah.
or just like mobile testing.
We have multiple kind of tests, like unit testing or integration testing. Some of the unit testing are actually running on Jenkins. Integration testing are also we have our own platform to support that.
So all the system is in your Kubernetes platform.
Not all of them. Yeah.
Okay.
We only have a part of our services running on Kubernetes today.
Okay, thank you.
Thanks.
The slide where you showed the various tools that you use in your ecosystems, Jenkins and so on, is not in the deck that's online. And I'm wondering if you could flip back to it so I could look at it one more time.
Sure. Yeah, we could definitely add that.
Thank you.
Cool. And no questions, I guess. Thanks for coming.